Hey guys, welcome to the session. And today we are going to discuss about the BGP topic, that is the BGP local preference. We'll try to do the deep dive. What is the BGP local preference? First, we'll try to understand and we'll try to do step-by-step labs as well. Likewise, we have done for the AS path prepend method. We done how it is going to be manipulate the path based on the AS path prepend. Similarly, we'll try to understand about the local preference, especially for this particular scenario. We are just going to talk about the local preference only. So last time also we have done discussion about the local preference, but that was like the mix with the AS path. So we try to understand which is the outbound traffic manipulation attribute and which is the inbound traffic manipulation attribute. So one of the inbound manipulation we have done, that is the use of the AS path prepend, but we'll try to understand what is the outbound manipulation and how it is going to be happen for the outbound manipulations. Okay, so we have the topology scenario. You can see the same topology we are using here, and in this topology what we are going to do, so we understand like outbound and inbound in the previous session, so I'm not going to repeat that all, but we'll try to understand how the local preference is going to work. So you can see we have the different labs here. So in the different labs, if I just scroll it down, so if you guys want to do just for the lab point of view, so we have the complete lab guides where the step-by-step scenario is there, right? And you just have to follow the step-by-step configuration. And based on that configuration, you are going to test that what is going to be configured on the R1, R2, R3, and R4, how the route advertisement is going to be happen in terms of the BGP, and step by step you can see that all the configuration is there, and then you have to like see how the iBGP peer is going to make, and then finally after making the eBGP and iBGP configuration you have to manipulate the route based on the local preference. So you can see here some kind of the output given, and finally based on the output we have the BGP summary, and in this BGP summary we have the traces, and based on that traces we come to know what is my current path and what is the BGP table is going to be happen, and then we are going to apply this is the local preference. So based on the prefixes we apply the prefix list, we created the route map, and then we apply the inbound direction of that particular BGP neighbor. So this is the most important inbound direction. So if we apply something in inbound direction, definitely it is going to manipulate your path outbound direction. I'll explain how it is going to happen, how they are going to be completely reverse. The applying the policy means the BGP policy via the route map in the inbound direction, how it is going to manipulate the routing decision for the outbound traffic. So if you guys want to refer this lab guide, you guys reach out to us, right? We're definitely going to provide that. The lab guide for the BGP, entire the BGP lab guide is step by step. Everything is written in this particular lab guide. If you want to do any labs, right, you can see the lot of labs are available, especially for the BGP. We prepared this. So MAD, BGP local path preference, path control, confederation, best path, ignore, aggressive address, wait, default route origination, how it is going to happen. We have the outbound route filtering as well. We have the route manipulation based on the aggregation as well. So you can just refer and can do the step-by-step process for the BGP configuration. Trust me, this BGP is the most important thing. Whenever people are talking about the SD-WAN, people are talking about the next generation things, but you are ISP things, but you are always going to find this BGP. So I'm not going to refer this lab guide because being like the BGP, like the expert, or you can say the BGP engineer or BGP, like whatever you can think about me, I just want to use my own topology. Okay, so I just want to give the real-time flavor scenario, how it is going to happen instead of just book is the step-by-step process. It is written in this particular lab guide. I'm not going to use. This is for the beginner who have just want to configure, they have the just want to do the practice and all, so they can follow the lab guides. Okay, so you guys can always follow the lab guide. There is no problem at all. So first thing we have to understand what is the local preference. Okay, so this is the one of the attribute of the BGP, and by using this attribute, if I go here, let me go a little bit down, so you will find that attribute. So you can see BGP path attribute, and in this BGP path attribute we have the attribute type origin, we have the attribute type the AS path, which have the detailed discussion in the previous session, and I hope you guys are aware about that. And the next is like the next hop multi, that is MAD, multi-exit discrimination, right? We have this, and then we have the local preference, that is type type code is 5. Different attribute have the different BGP codes as well. So this books is very nice. If you want to refer this internet routing architecture, this is a really nice book, and it is going to give the entire things for your all the BGP configuration and all. So you can see it is defining as a BGP local preference is the well-known discretionary attribute. So we have the well-known mandatory, we have the well-known discretionary, we have the transitive, non-transitive attribute. So different attribute type we have. So if we talk about what does mean discretionary attribute, that is a 4-octet non-negotiative integer. It is used by the BGP speaker to inform that BGP speaker it's on autonomous system of the originating speakers degree of preference for an advertised route. So might be this definition little bit complicated. So don't go on this definition. I'll make your life simple. Okay. So well-known mandatory and well-known discretionary attribute. What does mean? So well-known mandatory attribute is that the attribute is always going to be available with the BGP route. Okay. Means likewise, you can think about in this way. Well-known mandatory. Let's say I am the humans, right? And my hand always going with me. This is the mandatory thing. I cannot left my hand in my home and I can go to office. So you can think that means if my body is going to carry, my hand is the always going to like carry along with my body. I cannot like put my hand in my home. So it's a mandatory thing. You have to always carry something, right, to your office. But I want to carry my hand watch. Is it not mandatory? It's optional, or might be the discretionary. I can tell about, right? So it's not mandatory. I always have to carry. I can carry. I cannot carry. Similar thing is going to happen for discretionary. If I talk a discretionary attribute, these attributes are not mandatory, and it is not going to always carry with the BGP routes. Okay. So if I just go in the BGP routing table, I'll show you like how it is going to look like. So you can see this is topology. We are running the eBGP, iBGP here. So if I go in this CE1 and try to show you here, show IP BGP. So these BGP have the different attributes. So some attribute like this is the AS path. This always going to be available with the path, but this attribute is optional. It could be available, it could not be available. Okay. So this is a discretionary like, so this local preference is the discretionary attributes, and this attribute is not always going to carry. If you are going to carry, it is going to be carry, but this having the also limitations. This cannot be carried from one AS to another AS. This is the most important, guys. Means if you have any route, you are originating from the one location. Let's suppose this is the route and you want to apply some LP. Let's suppose this is your route. Okay, this route you want to apply the LP. So this route can carry till here, till here. This can carry. But if you think this can travel from my one AS to another AS, this is not possible. This cannot carry. So BGP local preference is always going to stay within the AS. If you have something LP value you want to configure here, this is going to stay here. This LP is also going to stay here. It is not going to carry from one AS to another AS. Okay. So this is the like the one of the attributes that is always going to be stay within the AS. So I hope you guys understand about it. What else? We have a lot of things in the books. So I'm not going to refer these books step by step. You guys can read it later. But if I go a little bit down, you can find about the decision-making process, how it is going to happen for the this local preference. Let me go here. Yeah, you can see here the local preference they are talking about. So this is the local preference attribute they are talking about. So in this local preference attribute they are talking, this is the well known. So this is going to known, but it's a discretionary attribute type code 5. This local preference attributes like degree of preference given to a route to compare with other route for the same destination. This is the most important guide. So let me read it again. So this is talking about the local preference attribute is the degree of preference given to a route to compare with other routes for the same destination. Means let's suppose I have to reach one destination within the AS. This is the another line you have to add. if you have to reach one destination, let's suppose your organization have one of the campus, okay? Building A, building B, two locations are there, right? Suppose, and you have the building C. You can just think in this way. Let me make a one diagram so you guys can understand what I'm trying to make a point here. So let's say entire, this is your campus. In this campus, I have this one building. This is the another building, and this is the another building. And you are here. This is the one path. You can reach to this building by going this way. This is one path. Another path, this might be going to this way. So one path might be the longer and one path might be the shorter. So the BGP local preference is going to compare these two routes and two paths, and they are going to tell which path is better to reach the destination. Means I'm just giving the example. This is not exactly it is going to take the path. It is going to take a route as a decision to reach the destination. But yes, it is going to tell and it is going to compare that how it is going to be look like and how decision is going to be made. And the another most important thing, the local preference always going to indicate some value, and more value is going to prefer. Let's suppose I have to reach two destination and one having the 200, one having the 100, right? Just think about the value, not talk about the meters. That's why I just make the longest path, shortest part, what I give the definition in terms of the comparing the two building distance. That is not realistic example, but these are the arbitrary values, okay? They are just a number. So if I have one of the route with coming with LP value 200 and this coming LP value is 100, so this is going to get a preference. So if this is originated by this place and I'm reaching via 200 to this PC and I'm reaching via this PC again via this particular 100. So this is always going to take this path because higher is going to take a precedent over the lower value. So this is again another thing you just have to take as a note. And by default, if you are not going to configure any AS local path preference, means AS local path preference, you are not going to command, the default LP value is going to be 100. So if two path is receiving the same route, the both are going with the same LP. So this is not going to manipulate your path. You have to move to another attribute. So just take a decision further manipulation of the path. Okay. So this is your LP value, which is going to be used here. Now moving to the next part. Once I done with the non-discretionary attribute, we discuss about this is a well-known discretionary attribute. This is going to stay within the AS. The higher value is going to be preferred and it is going to compare to route. Now the next thing is going to be happen is how BGP is going to be configured to manipulate the AS path preference. Okay. So in this scenario, if I just go in my lab scenario, so what I'm trying to do that, let's suppose I have to reach from this PC to this destination. So why it is outbound traffic and why it is very important to manipulate your outbound traffic and why we are going to apply in the inbound direction. So let's suppose outbound means this PC want to go this particular server, but I want this will prefer either this path or might be this is going to prefer via this path. I want to do that. Means I am going out from my network. So actually I want to go 8.8, 4.4, 2.2 or 1.1. This could be all prefix or might be the half of prefixes, might be 1.1 I want to go this as a outbound and 2.2 also and 4.4 for this one, 8.48 for this one. So this is how I want to do that. So basically how can I do that? What is the way of doing this particular labs? So first I have to understand from where I am receiving this route. From this place I am receiving this route. From this place I am receiving this route. So once I receive these routes, so I have to do some configuration on this router and this router, so that once this route is going to reach on these routers, they will carry some kind of the local preference value, because local preference is going to be just carry within the AS, not outside the AS. These all are going to belong in the same AS. That is the AS number 64002. So my traffic is going to be always stay within this AS. And once these are going to stay within this AS, so I can just compare the local preference value. Let me see how it is going to happen right now what is my trace, which path it is taking to going to this destination. So let me check that right now. And then we'll do the manipulations as well. So let me go in the user PC. First, let me try to ping whether 4.4 is pinging or not. It's pinging. That's good sign for me. Let me try to ping 8.8 as well. So it is also pinging. Let me try to 1.1. We have the basic reachability already BGP. I'm not going to configure, just watch the previous videos as well. This is also pinging. And this is my 4.4, 1.2.2. Okay. So these all are pinging. Now let me take a trace. How the traffic is going to be happen. Trace it. And let me go on the 1.1.1. So trace 1.1.1.1. So you can see this traffic is going. First hop is 192.168.10.2. Let me see. This 10.2 must be the R10 interface IP address. Let me check that R10. Let me check the IP address of R10. So IP interface brief. Yes, so you can see 10.2 is the R10 interface IP address. Okay, so this is landing on this particular router, and then it is going on the CE2 or CE1. Let's see, one having a 30 IP, 131. So let me see where it is landing right now. So it is going after that 31. You can see it is coming back to the R10, then again R9, that again this. So right now my traffic is going to this particular destination this way. First it is going to this, and then because we are running the IBGP between these all routers, that is backing to this, and then it is going to take part, and this is going this way. And why it is happening in this way? Let me see. So do you have any local preference configuration or not? So let me show you why it is happening in this way. So if I go on the C2 router and I try to check what is my route to IP BGP. Let me check 1.1.1. So you can see this is one route I'm receiving from 210 neighbor. This route I'm getting directly from this router. So I'm on the C2. Let me go on R10 first. Let me go on the R10. Show IP route 1.1.1.1. So this is known by the OSPF, okay? And because we are running the OSPF here, show IP route. You can see all route is the OSPF. So this is simple OSPF router, okay? So let me go here. We are redistributing from the BGP to OSPF, and that's why it is reaching via the IBGP till here. So let me go on the C1 again and try to check what is happening in this place as well. So let me go here, C1. So C1 must be have done the local preference manipulation here. So I'll reconfigure show IP BGP 1.1.1. So here you can see it is directly getting the route from that router, and it is just taking the base path as a, you can see 100 default local preference it is getting. And let me check show IP BGP summary, why it is happening this like. So this neighbor is down. You can see one neighbor is down. So this could be the one region. This neighbor is down. So let me check why it is down. So show IP interface. We'll correct it. This is up. Let me ping. So this is pingable. Let me ping 2. 2 is not pingable. The peer IP address. So let me go on the PE2 router. Let me first fix the issue. Then we'll try to do the manipulation. So show IP interface brief. And here I have the interface GE0/2, but it's not pinging. Let me check. 10.10.0.0.2 self is pinging, but it is not pinging to another route. So this might be the lab issue. So let me just stop these two router. What I'll do, simply stop these two router. I'll delete this link because this could be the virtualization issue, lab issue. So this link is probably hang the state. So what was the interface? Let me check. In P2, it was G0/2. 0/2. And what was the PC1? C1 also G0/2. Let me check it. Okay, so let me on it again. And probably after on, it is going to work. Then we'll see again because it is just taking the one path right now. So that's why the correct manipulation is not happening. So you have to fix that as well. So just wait for a while. We'll fix it very shortly. And then we'll test it again. If you have any question, please put your question in the chat. So I'll try to take the answer as well. So let's wait. So let me see what is happening here. So P2 is getting started. C1 is also getting started. And then we'll see how the BGP is going to form or not. And then we'll again check how the routing behavior is going to happen. And then we'll do the manipulations. Okay, so now you can see BGP is up here. You can see 2 BGP neighbors has been up. So I'm expecting 110 is also going to be up because it's showing the as per the logs. So it is going to fix because it was the virtualization issue, not more than that. So you guys have to no need to worry at all. So let me show I have a BGP summary here. So you can see now we have the BGP neighbor. This neighbor also is up and working. And if I just check this one also, so show IP BGP summary. So route is going to be converged very soon. So you start getting route. So now let me see again how the user trace is going to start happening now. So now you can see still the trace is going with the same path. Yeah, it is going to the same path, no changes at all. But let's see the route behavior as well. How the C1 is receiving the route now, because one route is coming from this path, one route is coming from this path. So this will give some LP value. This will also give some LP value. So we'll see which is going to preferred and why it is going to preferred. What is the logic behind it? One route we are getting the eBGP, one getting iBGP also. So how those attribute is going to help me in terms of the manipulations. So we'll try to understand step by step. So let me try to run the show IP BGP one by one by one by one. And you see now I start getting 2 copy of the route. 1 copy of the route I am getting from where? Let me, because this is a 1 copy of the route. And this copy of the route I am getting from the one neighbor. And this is another copy of the route that is getting from the another neighbor. But you can see both having the default LP. Right? But this is getting preferred as a best route. Okay. Now, there could be another problem. There could be another problem because this is the iBGP route. This is the eBGP route. So ideally, this should be preferred instead of this route. Okay. But this is newly installed route. So it might be this is not going to be converged very soon. So what I can do that, let me refresh that BGP table and we'll see that because as per the BGP attribute, let me show you. The BGP attribute is showing, let me go on the page. What is the page? That is the 149. So let me go on the 149 page. See here. This is. So the path selection process is saying that if I want to process the path, right? I want to process the path, then what is the step-by-step process to the the processing the path? The first step it is saying that if the BGP next hop is inaccessible, the route is going to be ignored. Then a higher weight is going to prefer, that is Cisco proprietary. Then after that weight, we have to prefer the local preference. But now you can see the local preference is same for the both of the neighbor. Even I'm getting the 100 here. So this is also 100. This is not one which is influencing my path at this level. Okay. for this particular route. Then what is the next? The next one is we have to check the AS path. Okay. The fourth was AS path, like if the route having the shortest AS path or longest AS path. So let me check the AS path detail. So you can see this route having the longest AS path, this having the shortest AS path. So this is the region AS path is getting shorter. Even this route is the IBGP, but still it is getting the installed in the my routing table. This is not getting the installed in the routing table. Still, this is the eBGP route. As per this, eBGP versus IBGP route will compare in this location. See, this is the next step. EGP, IBGP lower. Let me show you. eBGP preferred over the IBGP. This is the seventh attribute, but you are checking the AS path of the fourth attribute. So this will always going to take a precedent. So now, because my AS path is coming higher than this attribute, so it is going to preferred. So now what I have to do that, I want my traffic should go via this way. Means I want to go out from this neighbor. Currently my traffic is coming and it is going via this path, but I want to force them to go via this way. So it is always going to check the local preference first. You can say local preference is coming first. So if I go and configure the higher local preference, then this is going to be bypassed. This is always going to bypass. So let me do that. So what I am going to do that, even CE2 also you are going to see the route. So let me just check the route again. CE2, show IP BGP, any route. So you can see still it is getting preferred because this is the best only route, because this is just getting the one route here, and it is not comparing from other route. So it is getting just one best route here, but this is getting two route. One is the IBGP, one is the eBGP. Show IP BGP summary. So you can see I have the IBGP neighbor. This is my IBGP neighbor because the same AS number, and it is also receiving the IP. Let me say IP BGP neighbor. And if you want to check the receive route, you just copy, you just paste the route. It is going to show the all the routes. So you're just receiving this route. That is your internal route. Okay. So it is still like the IGP route is getting preferred. That's why it is not getting installed in the routing table. But let's see how I can manipulate my route. So simply what I can do, I can go here and create some prefix list. Let me see if I have any prefix list here. Let me see, show IP prefix list. Show IP prefix list. So there's no prefix list. So I'll go here in the configuration, IP prefix list, and I can put any DC prefix. Okay. This is my DC prefix, and there is 4 prefix /32. Oh, sorry, I have to put pomit here. So one prefix is here. Then again, I have another prefix 2.2.2.2. This is a second prefix, because all are getting preferred via the another route neighbor. So this is the 4.4.4.4. Okay. And this is your 8.8.8.8. So these are the prefix I just created. Now what I have to do that, I have to create some route map. Okay. So route map, it is going to create route map. And based on the, you can just think about the policy we are just doing here. So route map is going to be created, and this route map I can put local preference pomit 10. Okay. Match IP address. This is route map name, and you're just permitting the sequence, first sequence. If you don't know the route map, I'll cover in the separate video what is the route map and what is the use of the route map. But this is the way you can just do these manipulations. So route map permit IP address. Okay. And you just have to put the prefix list. And what is my prefix list? DC prefix list. Better you just copy it. Let me just copy and paste it. DC prefix. And then I want to set local preference. How much? So once I match this local base prefixes, by default, they're getting 100 local preference. So I want to make them increase. So what is my new local preference? So I can simply go and add the new value of the local preference. That could be the, let me add, sorry, it looks, let me see if my Okay, so I believe there was some internet connection issue. So you guys see here, right? So let me again show you. Show run section IP prefix. Show run section IP prefix. Include, sorry. So this is a prefix list I created, and just I created the route map. In between, my internet went down. Let's wait. I believe there is some issue in the internet. Include our section route map. So this is my route map. I'm just going to set the local preference. I want to make more than 100. So I'll just go again in this statement. I'll paste it, or let me do first this route map. This is done. I'll go in this match IP data prefix list, done. And the set local preference, this is by default 1. So I just mistaken created 1. But I have to make this as a 200, more than 100, or any 101. It should be always greater than 100. So I'll make the 200 here. So this route map has been created. Now what I have to do, I have to go in the BGP section. So there is a BGP section. And in this BGP section, I'll go in the configuration. In configuration, I'll go in the router BGP. And this is the magic is going to happen. See. So my neighbor, which neighbor is giving the route? So I have two neighbor. One is the iBGP neighbor between this to this. So you will find this neighbor as a, you can say this is the iBGP neighbor, 31. This is your iBGP neighbor. This is the eBGP neighbor. So this is also giving a prefix, which is the 100 LP. This is also giving a prefix, which is the 100 LP. So what I'm going to do, I'm going to tell if you're receiving any prefix from this neighbor, means if you're going to receive any prefix from this neighbor, so these routes are coming from this direction. So it is going to apply in the in direction. And I'm going to tell him, if you just receive this prefix in the in direction, just apply here LP 200. So it will give the route, the same route here. This all route will also come via this way, but this time LP will be the 100 only. So now this router having a same route, one is coming from this place with LP 200, this coming from this place LP 100. So this will win the game, and they will prefer this path as a primary path, and the traffic start going via your eBGP neighbor instead of the iBGP neighbor. So let me do that. So you just have to apply in the in direction so that your traffic can be manipulated for the out direction. You're going out. So in means it is going to send the LP within the AS as a higher AS. So let me go here again. I'll go in this particular section and I'll go in the router BGP here. Already I'm in the router BGP. I'll go in the neighbor. This is my neighbor. And I'll put the route map, and I'll put the route map name. And what is my route map? This is my route map name. Okay. So I'll just copy it. And let me, sorry. And the direction I would be, I'll apply the in. So I'll receive, then I'll going to apply. So I'll just apply the in and I'll just control Z, I'll go out. So let me write this. So once I apply the policy, and I'll try to show you how my route is going to be look like. So let me show you, show IP BGP summary. So you'll first see the route map here. And if I just try to check, so IP BGP 1.1.1. So still it is getting the route. Okay. But this path is preferred. This LP is not coming in picture. So let me, yeah, now you can see this was the old output, but if we compare with the new output, it was take a little bit time to get convergence. So you compare this was the 100 LP and this path was not preferred, but you can see the same, we have the highest AS path prepared, but this time I have the 200 LP and this path is getting best path instead of the higher AS path. Even I am getting the higher AS path. This is getting the best path. Why it is happening? Because we manipulated the path. So if I go on the user again, I try to do the again trace here. Let me do that. Let me try to open this PC again. Show IP. And I try to trace 1.1.1. You'll see that now your traffic is start going from the 30 instead of 31. So earlier it was going via this path, this was, now it is going directly from this, directly this, and directly this. You can see because 110 is coming in the picture. So this is how, based on the local preference, you can do the manipulations. So if you guys any question, any comment, write in the comment box. So I'll just review that. And if I need to make the special session, a special discussion on that, so I'll just create that. But this is how LP is going to work. Not anything else you should know about the LP. Just you know about this. Let me go here and search about the local path preference, about the theoretical. So if you go here, BGP local preference, so you just try to search it, you'll find there is an attribute. So you can see here BGP local preference is a local preference. This is the discretionary attribute, well-known discretionary attribute that has helped to choose the exit path from an autonomous system. Means you want to go out from the autonomous system, then LP is going to help you. So this is going to influence your outbound traffic, but it is always going to apply in the inbound traffic, right? So the default value of the LP is the 100, and selection, path selection, highest local path is going to be, means highest LP is going to be chosen as the best path. How it is, this, it is going to send all internal BGP router, not external, within the AS. So significance of the local preference is always going within the AS. Interviewer is going to ask the question, what is the significance of the local preference, where it can be stay? So the answer is within the AS number. So it is always going to influence the IBGP neighbor, not eBGP neighbor. So, but not exchange to between the external BGP router. It's a clearly mentioned here. You can see when it used to configure AS to select the particular exit point, means you want to send traffic some exit point to manipulate the outbound traffic. How is different from the BGP wait? So we didn't discuss about the BGP wait. So BGP wait is the attribute that is for the Cisco proprietary. It is going to work within the Cisco router only. This is the one most important thing. And this is going to apply within the single router. Means if we have this scenario, right now, why I'm talking, I have the two router. They are in the same autonomous system, right? They have two links and they are receiving the prefix. I want to compare the best route between these two. So I have to use the LP. So AS is going to play a vital role within the AS, LP is going to play. But let's say I have the single router, right? I have the single router and I have the two links here. And one is sending the route from here and same route I'm giving to here. So I want to manipulate the route. How it is going to happen? So I can use the wait. So wait significant, it is always going to stay in the local to the router, not the AS. Even the router itself is going to take a decision. So wait is the local to the router, while BGP local preference is the local to the AS wide. Means local preference is going to stay within the AS. How many router, I don't care. But the normal wait is going to stay within the one router and just it is going to care to just manipulate the path. And it's also the Cisco proprietary route, means the attributes. So this also you have to take care in your mind. Additionally, if I just click on the any other links and you want to read that, so you can see BGP local path, second attribute, why seconds, you can see here. The first is like your first of inaccessible, then they are going to check the wait. And then the same like third one is the local preference, right? Technically it's a second, that's why they're talking the second attribute, right? You can use the local preference, choose the outbound external BGP. So if you want to manipulate the outbound traffic, then it is going to be accessible. Local preference is sent to the all BGP peers in your autonomous system. No exchange between the external BGP router. It's have to be take care special. And additionally, local preference is well-known discretionary BGP attribute. And the default value is going to be 100 and highest is going to be preferred. So you know now how it is going to be configured. What is the step-by-step the decision is going to be taken by the router for the manipulate the routing process. And how my routing is going to be influenced and how the route map is going to be created, how it is going to call the ACLs or might be prefixes in the route map, and that is going to apply in the inbound direction. Then it is going to perform the outbound manipulation. So I hope you guys really enjoy this session, and I hope I have contributed a little bit to upgrade your knowledge. If you really like the session, just show your positive response. Even you are not like, then you can just give us a suggestion. We'll try to improve and try to make a more. Definitely, this session is going to be one by one. Every attribute is going to cover. So you are going to find in our channels. Definitely, you are going to get some inside knowledge about the BGP attribute. But yes, end goal, you should get something and you should able to upgrade yourself. And trust me, BGP is always going to be used. Even you are talking with the SD-WAN, underlay is always BGP. You are going to talk about the ISP network, underlay is always going to be BGP. So BGP you must know. Or likewise, the routing protocol, OSPF, gRPO, static, RIP, you should also very good hands-on on the BGP routing protocol. So thank you guys. See you again. Bye-bye. Take care. Have a great